Hello, in this video we are going to solve this exponential equation. We have n power 6 equals n minus 1 all power 6, and we are solving for all the complex solutions and real solution. So let's go ahead and do that. What we are going to do is we can rearrange this equation and we can have n power 6 minus, we have n minus 1 all power 6, and this equals 0. The next thing we are going to do is we can rewrite this n power 6 as we have n power 3 or power 2 minus, we do the same thing here, we can have it as n minus 1 power 3, then this is raised to the power of 2, and this equals 0. So right now, if you multiply these two exponents, you are going to have 6, and if you multiply 3 by 2 again, you are going to have 6. Now look at what we have here. The exponent here is 2, and the exponent here is 2. So we can make use of difference of two squares, a squared minus b squared, and this equals a plus b times a minus b. And from this particular equation here, our a equals n power 3 and b equals, we have n minus 1 power 3. So that means if we make use of this difference of two squares here, a plus b, we are going to have n power 3 plus we have n minus 1 power 3. Then for a minus b, we are going to have n power 3, let me use square bracket, then we have minus n minus 1 power 3, and this equals 0. Now we can make use of this other identity. This one here is in the form of a power 3 plus b power 3, which equals, we can make use of this identity, a plus b times we have a squared minus ab plus b squared. Then this other one here is in the form of a power 3 minus b power 3, which equals, we can have a minus b, then we have a squared plus ab and plus b squared. So we are going to apply these two identities right here. Where we have this one here, we are going to apply the first one, and when we have this other one, we are going to apply the second identity. Now let's start with the first one here, a plus b, meaning that from here our a equals, we are going to have m, and b equals, we are going to have m minus 1. So let's take note of that. So for the first one here, a plus b, we are going to have, let me make use of square bracket, m plus m minus 1. And for this one here, we are going to have a squared, that is m squared. Then we have minus ab, we are going to have m into m minus 1 plus b squared, we are going to have, then let's proceed to this other one here, and we are making use of this identity. So we are going to have another square bracket. So let me bring it down. A minus b, we are going to have then we have a squared then we have plus ab, then we have plus b squared, and this equals 0. So we have been able to express this given equation using these two identities. So right now, let's actually work on what we have here. So m plus m minus 1, this will give us m plus m, that is 2m minus 1. And here we are going to have m squared, we are going to have m squared. If you expand this, we are going to have negative m squared. Then we have plus m. Then if you expand this, you are going to have plus we having m squared minus, we have minus 2m plus 1. Then this one here, we are going to have, let me bring it down, m minus, if you expand this, you are going to have positive 1 because m will cancel m. So this will give us 1 because m will cancel this minus m, and we have minus times negative 1, we are going to have 1. Now this other one here, we are going to have m squared. Let me start there. Then if you expand this, we are going to have plus m squared minus m. Then we have plus m squared, if you expand this, minus 2m plus 1, and this equals 0. So that means what we are going to have is, let me take this one, we have 2m minus 1. Then let me work on what we have here, m squared minus m squared, this will cancel. Then we have m squared, positive m minus 2m, we are going to have negative m. Then we have plus 1. Then this is 1, so we neglect that. And for this one here, we have m squared plus m squared plus m squared. That is 3m squared. Then you have negative m minus 2m. You have negative 3m. And we have plus 1, and this equals 0. So right now we have 3 different equations. That is, the first one will be m2m minus 1 equals 0. Or we have m squared minus m plus 1 equals 0. Or we have 3m squared minus 3m plus 1 equals 0. Now for the first one here, this will definitely give us a real solution. If you have 2m minus 1 equals 0, that means you are going to have 2m equals 1, and from here we are going to have m equals 1 over 2. So this becomes one of the solutions. This is the real solution. Now let's solve this other one here. So we have m squared minus m plus 1 equals 0. We can make use of formula method. We make use of m equals negative b plus or minus square root of b squared minus 4ac divided by 2a. So from here, a equals 1, b equals negative 1, and c equals 1. So we are going to have m equals negative b, we're going to have 1 plus or minus. We have square root of b squared, we're going to have 1. Minus 4ac, we are going to have 4 times 1 times 1. And we have minus 4 divided by 2a, that is 2. So we are going to have m equals 1 plus or minus root of negative 3 divided by 2. And because of this negative sign here, we can introduce imaginary number I, and this equals 1 plus or minus root of 3 times I divided by 2. Now this is second solution for m. Now, and this is a complex solution, we can also solve this other equation here, this third one, in order to find the value of m as well. So we'll copy it down here. We have 3m squared. 3m squared, then we have minus 3m. Then we also have, let me copy the last one here, we have plus 1, and this equals 0. So let's also make use of the formula method as well. We are going to have m equals negative b plus or minus square root of b squared minus 4ac divided by 2a. And from this particular equation, we have a equals 1, a equals 3, because the coefficient of m squared here is 3, b equals negative 3, and c equals 1, which is the constant here. So we insert it into the formula. We are going to have m equals negative b. We are going to have 3 plus or minus square root of b squared. We are going to have negative 3 squared, that is 9. Then we have, this is minus 4ac, that is 4 times 3 times 1. This will give us 12 divided by 3. Divided by 2a, and 2 times 3 is 2 times 3. So we move ahead. We are going to have m equals 3 plus or minus. This will give us root of negative 3 divided by 6. And because of this negative here, we can introduce imaginary number I. So we are going to have m equals 3 plus or minus root of 3 times I divided by 6. So in total, we are having 5 solutions. We have m equals 1 over 2 for the first one. Then this one, we have this one here, 2 solutions. We have 1 plus or minus. We have m equals 1 plus or minus root of 3 times I, then divided by 2. And finally, we have this other one here, m equals 3 plus or minus. We have root of 3 times I divided by 6. Now we are having 5 solutions in total. So out of we're supposed to have 6 solutions if you look at the problem very well, because we are having m power 6. Here we are having m power 6 here. But the issue is, if you actually expand this, out, you're going to have m power 6 equals m power 6, then the rest of the expression. So that means m power 6 will definitely cancel m power 6. You are going to have m power 5. So that means you are going to have 5 different solutions, because there will be a point that m power 6 will cancel m power 6. So that is it for the video. We have 5 different solutions, and I believe you have gotten a value. Please don't forget to subscribe, share the video, and drop a comment. Thank you.